guys, welcome back to another Discrete Math tutorial. Let's continue on with working on a few examples. So in the first example, let P and Q be the following propositions. P, it is above 90 degrees, and Q, it is humid outside. And basically what we want to do is to write these propositions using P and Q and any logical connectives. So for the first statement, it is above 90 degrees and humid outside. So right here, we have this and connective. Right here is your first statement. It is above 90 degrees, which basically is P right here. So that would constitute P. We know our and symbol is and, humid outside. This can be rewritten as it is above 90 degrees and it is humid outside. So P and Q. For our next one, we have it is above 90 degrees, but not humid outside. But in discrete math can almost always be treated as an and. Not is the negation of Q. So this one will be P and not Q. Since Q, it is humid outside, not Q, it is not humid outside. In the following example, it is not above 90 degrees and it is not humid outside. We see that with the not here and the not there, both of the statements are negated. And then we also have a conjunction right here combining these two statements. So not P and not Q. The following sentence uses the or operator. We also see that the or both is stated right here. So we know that it can either include this one or both, which means it's a disjunctive or. So that states that it is either humid outside or above 90 degrees. This is another keyword for that or. So P or Q. So the next one, if it is above 90 degrees, it is also humid outside. So this is our basically if-then statement. We could have also said this: if it is above 90 degrees, then it is also humid outside. So since this is our first statement, second statement, process conclusion, P implies Q. The next one, either it is above 90 degrees or it is humid outside, but it is not humid outside if it is above 90 degrees. Seems like a tricky one, so let's go ahead and put it down here. So either or, so we'll go ahead and put this, either it is above 90 degrees, so either P, or humid outside, or Q, but, so we know that's an and. This one is a little bit trickier. It is not humid outside if it is above 90 degrees. This if statement signifies that this portion is the hypothesis in the implication. So if it is above 90 degrees, it is not humid outside. So this we would have to write, since this is our P, so P implies not humid outside. So this is our Q, it is humid outside, so the negation of Q. So this one's a little bit hairier, but still we could work through it. P or Q, and P implies not Q. The last one is our biconditional statement, that it is above 90 degrees is necessary and sufficient for it to be humid outside. So this basically states that if and only if it is above 90 degrees, then it is humid outside. So P, if and only if Q. Let's look at another example. What we want to do is determine whether each of these conditional statements are either true or false. So if 1 plus 2 is equal to 3, true, then 3 plus 2 is equal to 6. 3 plus 2 is equal to 5, so it does not equal 6, so that's false. True cannot imply false, so this statement is false. For the next one, if 1 plus 2 is equal to 4, well, that's false because 1 plus 2 is equal to 3. Then 3 plus 3 is equal to 6. Well, that's true. Although the hypothesis is wrong, the conclusion is true. False implies true is, as a matter of fact, true. For the next one, if 4 plus 1 is equal to 7, that's false. Then 5 plus 2 is equal to 9. That's also false. False implies false is true. And let's look at the last one. If pigs can fly, false. Then 2 plus 1 is equal to 4, which is also false. False implies false is, as a matter of fact, true. And I think we'll end this tutorial here. Make sure to subscribe for your daily discrete math tutorials.